Okay, so we're going to look at parametric equations. Okay, so the first thing then is to know what they are. So first of all, we've been dealing with Cartesian equations up until now, really. And there are ones that include x and y. They're called Cartesian equations after Descartes. And you'll be sorry you're not in school to hear me give you lots of boring stories about Descartes. Okay, so then parametric equations. This is where x and y are described by another variable. It could be theta, it could be t. So x is described as some function of t and y is described as some function of t. So the first thing we have to be able to do is to go from a parametric to a Cartesian and to deal with parametric equations. And then once we're happy with that, we'll move on to differentiation. Okay, so our first example then, draw the curve y equals 2t and y equals t squared for t between minus 3 and 3. So our first method then for doing this is to say, okay, well, our t values are between minus 3 and plus 3. So what would our x and y values be at these points? So when t is minus 3, x is 2t, so that'll be minus 6. And this will be minus 4, minus 2, 0, 2, 4, 6. Then y is t squared, so minus 3 squared is 9. This will be 4, 1, 0, 1, 4, 9. And then we're going to plot our x and y coordinates. And hopefully I can get this fitted in here. So we've got 1, 4, and 9 here. And that's 2, 4, 6 on the x axis. So when x is minus 6, y is 9. When minus 4, y is 4. When x is minus 2, it's 1. When x is 0, y is 0. And then up the other side, we get our points and we sketch the curve. And this should be a quadratic, like a nice smooth curve. That you're drawing it like that. Okay, so that's our first method. Our second method then is to transform our parametric equations into a Cartesian equation and then just sketch the curve as you normally would. So when you're doing that, you're basically changing the subject of the formula. So if x equals 2t, that means t equals x over 2. Now we're going to substitute that in. So y is going to equal x over 2 all squared, or we can write that as x squared over 4. Now, we said that the question said it's going to be between, for t is between minus 3 and 3, so that means x is between minus 6 and 6, and then it would be up to you what points you find. If you want, you could do from minus 6 right through to 6, or you could say, well, it's a quadratic, and we know the shape of a quadratic. So I'm just going to find the endpoints by substituting our x values in here. And then obviously it's the same graph as we drew in the previous method. And that should be a nice smooth curve, obviously, when you draw it. Okay, so our second one then. Curve is described by x equals t minus 1 and y equals 4 minus t squared. Find the coordinates of the points where the curve crosses the x-axis. So where it crosses the x-axis, that means that y is naught. So we'd have naught equals 4 minus t squared, which will give you t squared is 4, which will give you t is plus or minus 2. So when t is 2, x then is t minus 1, so 2 minus 1, which gives us 1. When t is minus 2, x is minus 2 minus 1, which gives us minus 3. So our answers then, it crosses at minus 3 naught and 1 naught. Okay, so our next one, a curve has parametric equations x equal at and y equals a upon t cubed plus 8, where a is a constant. The curve passes through the point 2 naught, find a. So our coordinates are still Cartesian coordinates, they're still x and y. So that's our x value and that's our y value. I'm going to take the y value first. So naught equals a upon t cubed plus 8. Well, the only things that can make that naught are if a is naught or if t cubed plus 8 equals naught. Now this a equals naught doesn't make any sense because it would make your two equations, your equations over here, it would make them both naught. So it just doesn't make any sense. So then let's look at the t one. So that would give you a value of t equals minus 2 would make this 0. So then our x value is 2. And we've worked out that t is minus 2. So then 2 divided by minus 2 is a. So a is minus 1. Okay, so a curve has parametric equations x equals t squared and y equals 4t. So that's our curve. The line x plus y plus 4 equals naught meets the curve at a. Find the coordinates of a. So if you had a curve just in Cartesian form, so y equals 2x squared plus 3x minus 4 or something, anything, and it was meeting a line, you would set them equal to each other. You would do your one linear, one quadratic, and you'd find out where they meet. So what we need to do is we need to get our parametric form and change it into a Cartesian form. So x equals t squared and y equals 4t. So t is y over 4. So we can write then that x is going to be y over 4 squared. So x is y squared over 16. So that's the equation of our curve. And then we're going to use that, substitute that into the equation of the line to find where they meet. So our line is x plus y plus 4 equals 0. So y squared over 16 plus y plus 4 equals 0. So first of all, multiply across by 16. Factorize your quadratic. We'll get that y is minus 8. And then substitute that into our, to either equation. And we'll get x is y squared over 16, so 64 over 16. So that's 4. So the coordinates for a are 4 minus 8. Okay. So a curve has parametric equations x equals sine t plus 2 and y equals cos t minus 3. Find the Cartesian equation. Now, you get this a lot with trig in it, and it could be sine and cos is the most common, but it could also be any of your other identities, sec and cot and cosec and all the rest. What you want to do is to find the trig identity that's got the appropriate ratios in it. So we want to find the trig identity with sine and cos in it. So we all know that sine squared plus cos squared is 1. So if x is sine t plus 2, then x minus 2 would be sine t. So we can replace the sine t here with x minus 2. So sine squared then would be x minus 2 squared. Then with y, bring the 3 over. So cos t is y plus 3. So we get y plus 3 squared equals 1. And any of you that are wide awake, you can see that's the equation of a circle. Our last part then, find the Cartesian equation of the curve x equals 1 minus t and y equals 3t squared. So what you want to do in all of these types of questions is rearrange one and change the subject so it's t equals something. So I'm going to use this one. We bring the t over, that becomes t equals 1 minus x, and then we substitute it into y. Now, depending on the question, you could just leave it like that. If it wants you to multiply out the bracket and stuff like that, it'll tell you to leave it in a particular form, but this is perfectly acceptable as your answer.